Hello and welcome in, everyone. I am your host, Code Wonderland, and today we are playing some Comet 64. Now, if you haven't been watching through this playthrough, shame on you. Go back, watch the beginning, figure out what this is about. But the TLDR, if you're just sticking around from here, we are going through a bunch of programming puzzles that are based around the style of programming that you would have used for the Commodore 64 back in the 80s. Uh, Commodore 64 is just a wonderful machine. One day I would love to have my hands on one of them. But we left off, we got through 7 of the challenges in Disc 3 in one singular episode, and then they threw really tough ones at us at the end of it. We started messing around with this one, which is just reversing a string. You would think it wouldn't be that hard, but I was overthinking it. I looked back at the user manual, and in particular, I noticed this line. So before, we had this concept of I was trying to create a copy of the string. Specifically, we need to create a reverse copy, but I was like, alright, well, if I'm going to use indexing to update the character of a string, so like in the reverse, I couldn't just do after I switch string int equals car, like something like that. I could, actually no I couldn't, because it would be an empty string. There's no indexes to swap out. But there is string concatenation. And unlike regular programming, all of these registers initialize to their default values, which for string is an empty string. An empty string can be concatenated to. So we can just do string plus park. So let's look at that kind of approach instead. So string equals string plus car. And we don't really want to be adding this one, now that I think about it. We really want to be adding string length -1, and then we reg minus minus. Well, wait, we're using int here, reg. Let's just use int, because we're using integer data. Use the right thing for the job. Been a little bit laissez-faire with that, but in real-world context, you shouldn't be using a float value for an integer. It's way more costly. So we got car equals string int, switch string equals string plus car, switch string, and then check int greater than 0. Actually, hold on a second. I kind of want to put this up here. Yes, because then we start at the right value, and then we'll go through all of the indexes, including 0. Then we check to see if that's greater than 0. Jump if true loop. And then otherwise, we switch back the string and output equals string. And that seems correct. Actually, because we're doing this, string equals string plus car, let's reset. Switch. Is it just switch null? Yes, just switch null. Switch null at the end. That's to clear switch. Alright, let's run that. Bada bing, bada boom, perfect. And look at that. First try. Well, I guess we tried last time, so it's not quite the first try. But first try for this episode. So, for all you know. Alright. So, this one, honestly, so we looked at what each of these were last time, and I've been thinking about them in between the episodes here. This one seems more approachable than this one. I'm intimidated by this one, honestly. Um, so I think, honestly, I'm gonna start with this one and then go back to. Wait, what? We've already unlocked the code? I really have not been paying attention to when these unlock, so we've already unlocked the code there. I didn't realize that. That's pretty cool. Alright. It's a recap of what these are. So this one is reverse the string, this one is alphabetize the string, and this one is replace the numbers with Roman numerals. I think the numbers with Roman numerals I can do pretty straightforwardly. So let's start. We got int equals input. And let's see. What cases are we doing? So honestly, I really like that this is right here because this is still Comet 64. But this reminds me that, like, alright, so 50 is L, 10 is X, 5 is V, I is 1. I knew these three. I would not have remembered L, not gonna lie. Do we have inputs up to L? Not here. Maybe? Let me just output equals int for a second. Nah, we don't need to account for 50s. Just because that's a whole extra section of code. Alright, so then let's account for 10s. I mean, I guess let's just make a little label for it here. So, how do we want to do this? So do we just check to see if it's like... So check int greater than 9. Right? And then... Come on, brain. You got at least 2 neurons in there. I know they can fire. I promise they can fire. So if it's not greater than 9, then we need to do 5s, right? And then if it's not greater than 5, we need to do 1s. That's not entirely the case because we do IX for 9. So we actually do need to include 9. So 8. So we'll need to include 4 and 5 for 4. So, okay, so if it's greater than 10, so jump if false, and we'll make this the 5s, and then we'll have 5s down here, and then 1s, and then probably an output answer at the end, but... So... I mean, we could probably just put everything in string, I would assume. So, int... How on earth is this gonna work? So this is for 9 and 10. So if we subtract 10, and then check int greater than 0, right? Because if it's a 9, then it'll be a -1. Because we only have the 2 cases. So what do we do if it's a 9? We add an I first. Okay, so... just a little add I. Can I do it? I'm gonna do it up here. Or should I do it here? I don't know, I'll do it here. String equals string plus I. Jump if false, add I. And then do I just add the X right here? Hold on. Because normally I would just put it like right here, but I need to do it in both cases. I guess I could just put it in both cases for now. So string equals string plus X. Wait, but would that work here? Because I also need to use this for 5s. Because 4. I don't need to use it for 1s. So let me actually move this back down. I think my initial intuition was right, that it's something that should go down here. Isn't that what return does? Doesn't it go back to the jump statement? Where on earth is that? Yeah. Because I messed myself up trying to use that for something else before. So if I just type return there, I should jump back to this. And then let's do the same kind of thing here. So check int greater than 4. Yep. Jump if false once. Int equals int minus 5. Check int greater than 0. Jump if false. Add I. String equals string plus V. Okay. And then we need to add a check in here. That's how we keep these looping. So check int greater than, do we do 10 or 9 here? Or 8? Hold on. So if we subtracted 10, we're still gonna do things. Wait, why not just loop back to 10s? Otherwise, if we jump... Yeah, hold on. Jump to 10s. And then jump to 5s. Yeah, okay. Okay. And so it'll keep looping on itself until it fails this check, and then it'll send it on to the next one. And then I feel like this is probably going to be much like the other ones, but simpler. So let's check int is greater than 1. Jump if false. Output answer. Int equals int minus 1. There's no add I here, so string equals string plus I. Jump to 1s. And then we need to just fill out output answer. So output equals string. Do I need to clear anything? No, right? So it gets cleared immediately. String is just being cleared like this. Yeah, so I'm gonna need to probably do a string equals null. Is that how you do that? It's how you do. It's kind of like how you do switch. Let's try that. We failed. No, that did not work. Okay. Wait, but it is being. How does that work? I don't know. I don't know. But somehow it was being cleared. How though? That's what I truly don't understand. Because I'm not directly assigning anything to string at any point. Yeah, see, now it fails. So I do need to reset it. Oh, I see, because I did the... I got it. I got it. Alright, so string... I think I got this. So switch null, switch string. I failed? Why? Hold on, wait. This needs to be greater than 0. I thought it needed to be greater than 0. We got some of these. We're failing here and here. So this should have just been XX. And it's XIV, and then it should be XV, and it's XV. It's IX. Why is it doing that? Does this need to be check int greater than -1, and this needs to be check int greater than -1? Ooh, we're close. We are close. Oh wait, we messed up on 5s here. This needs to be 3. Hey, I think we got it. Look at that. Alright. Alright. Pretty clean. Pretty clean. Look at that. And I gotta say, it's one of the better organized ones that I've done too. I don't really like this at the end. I'm gonna put a little comment because I feel like that makes it cleaner. Clear string. There we go. Now here's the one that intimidates me. So sort each string and input alphabetically before outputting. Okay. So the way that we managed this last time for reversing was this. Let's copy this over for some kind of reference to look at. So before we were just going through each one and then we were appending it to an alternate string kept in switch, and then we cleared switch at the end. Now we need to compare if one is greater than the other. Now, can I do that directly with characters, or do I have to do that? Well, no, because I don't have 2 character registers, so I'm going to have to do it with character and int or character and reg. Right? Because I can compare those 2 directly. Where on earth is this? I don't know. My assumption is that if I do check reg greater than char, or car rather, that'll work perfectly fine. And so then I can compare each element in the list. I'm gonna need to... Wait, am I gonna need to swap the string and an int? Because that's not gonna work. Do I have enough data slots for this? I mean, obviously I do, but maybe not the way that I'm thinking about it. Sort each string and input alphabetically before outputting. I mean, I think probably the easiest way to go about this would be to do something like a bubble sort, because it's pretty straightforward, and it works as an in-place sorting mechanism. And the way that you do a bubble sort is terrible in operations, but you compare each instance of a or like each character in the list of strings. So think about a string, a phrase, so like Lisa, it's technically 4 different characters, so we can treat it as such. That's why we're indexing it at different points like this, like string int, because if we're looking at 0 index, so this is the 0th character, the 1 character, 2, 3, or the reason why we call that, at address 0 we have L, at address 1 we have I, at address 2 we have S, and address 3 we have A. So then we would say, alright, we'll look at this one first as our first character, so let's do this. And I found going in reverse actually works better just because we don't have that many variables. So instead of comparing, we can just inverse. Reg equals int. For now, reg equals int. And so our loop is int, and actually, int minus 1. Okay, so car equals string int. We're assigning a character for that element. And then, do I need to switch the character? I think I can switch the character here. So switch. Well, no, because I need the character, right? Because I just pulled that character. I need to compare it to other characters. I don't need this int for a while. Not until we come back to the top of the loop. So, does that enter key not work? Huh. The enter key on my numpad does not actually get recognized in this game. That's interesting. So switch int. Oh, this is gonna cause problems with this later. It probably is. I'm positive it is, honestly. Although, actually, do we need this? Because we're swapping things in place now. Probably not. So we switch int, and then now int equals string reg. I think. And then can we compare those directly now? Because... Wait, isn't that the same character? Is it the same character? I have no idea. Wait a second. Wait a second. I feel like my math's wrong. This needs to be off by 1. right? Because that's last index. This also starts as the last index. Int. No. What? Yeah. Reg minus minus? Maybe? Oh, I'm so lost. But we'll keep going with it for a second. So int is our main value here that we're our first value for the initial car that we're testing against. And then yeah, that makes sense, right? So now we can check if int less than car. If false, loop. Otherwise, swap characters. And hold on, I gotta think about which variables which now. So currently, int is the character at reg, and car is the character at the switched int. So car needs to go to reg, and int needs to go to switched int. Ooh, that's messy. I don't know how we're doing that, but we'll figure it out. So first and foremost, the easier bit is string reg equals car. Okay. And then car equals int, switch int, string int equals car. All right. All right, so then we have check int is less than 0, jump if false, to loop. That's a little bit cleaner than before. And do I actually want to do reg? Yeah, I think I want to do reg. And I don't think I need this anymore. Is that it? Hold on. So string reg is not numeric, cannot be written to int. Let's try it to write it directly to car. That's on line 9. Oh, that's way more complicated than I realized. Oh god. Oh no. Oh no. Alright, we're already at 30 minutes, so this might be something we pick up on next time, because I'm just realizing I might need to double my code here. So until next time, if you like the channel, if you like the content, please subscribe. Every subscription counts. Like, comment, interact with the videos. Check out the other videos in the series. We also did a great The Farmer Was Replaced series a while back as well. And if you're looking for more traditional kind of gaming, please check us out on Twitch at twitch.tv/CodeWonderland. But until next time, bye.